Hi, do you ever imagine how to alter your electronic waste into a more sustainable product? Today, we would like to introduce you an idea which is called electronic waste utilization through metal extraction as the basic substance of SMA for solar PV system mechanic drive in Indonesia, and brought to you by us, Ubay, Atzana, Nindya, Naufal, and Darmesta. First up, introduction. In 2014, the amount of e-waste globally was up to 40 million metric tons and is increasing in 2016 up to 44.7 million metric tons. The Global E-Waste Monitor predicts that these numbers will increase up to 50 MT by 2019. Asia contributes the highest amount of e-waste. 40.7% of global e-waste is in Asia. Indonesia contribute 4.9 kg per inhabitant in 2016 for Asia. Electronic waste contains a plethora amount of metals such as lead, cadmium, chromium, even PCBs, and it is very harmful for health and gives contamination to the environment. Those are the reason why the authors aim to extract some of the e-waste substances such as nickel to create a microactuator named SMA that will help mechanical movement of solar photovoltaic system in Indonesia. The objectives of our research is to determine the method to extract metals from electronic waste. Second one is to determine the possibility of shape memory alloy created each year, determine the potential utilization of shape memory alloy in solar PV, and also determine the correlation between e-waste metal extraction with sustainable development goals. Second one, literature study. SDGs, or Sustainable Development Goals, are a group of targets set by the UN that contain the development plan to achieve a better and sustainable future. It comes with 17 different goals, continuing its precedent goals, the MDGs, or Millennial Development Goals. The focus to this idea is SDGs number 3, 6, 7, 8, 11, 12, 14, and 15. Now, electronic waste. Electronic waste or e-waste is scrap electrical or electronic apparatus such as mobile phones, laptops, and refrigerators. These wastes are en route for reconditioning, reuse, resale, recycling the valuable material or disposal. Based on EU6 classification, we can see the category as depicted above. Now, the statistics of e-waste globally. Composition statistics say that production of screens contain equipment based on EU6 standard needs 1.5 tons of water, 48 pounds of chemicals, and 530 pounds of fossil fuels. Small IT and telecommunication equipment based on EU6 standard contains precious metals that can be produced into valuable components such as gold and silver. Electronic waste mostly contains lead that can cause health damages, such as cardiovascular diseases, kidney abnormalities, and also nervous diseases. Globally talking, Asia contributes the highest in the world, remaining 40.7% of global e-waste every year, followed by Europe with 27.5%, America 25.3%, Africa 5%, and also Oceania such as Australia and New Zealand contributes to 1.6%.
E-waste in Indonesia is not directly disposed to a landfill or a recycling plant. Instead, the e-waste is being reused or being cannibalized for another application. The source of e-waste in Indonesia is household, office, and commercial areas. In Java, Indonesia, the e-waste handling are mostly done by the informal sector. The handling processes, however, resulting toxic and emission to the environment. Shape memory alloy is a kind of microactuator. It is also a type of material that can memorize its predeformed shape. There are two types of shape memory alloy, one-way and two-way. One-way SMA can hold its shape to a certain temperature and it will change it to its original shape when it cools. It will hold its hot temperature shape. This type of SMA is mostly used in pipe joint, and the other one, the two-way SMA, can memorize two different shapes at hot and cold temperature. This type of SMA is proposed to use in solar photovoltaic system. Shape memory alloy can be implemented as joint steel pipe, crane rail joint, and solar PV mechanical drive system. And the basic principle for the solar PV mechanical drive system is when the sunlight hits the SMA, it will deform and so it will direct the panel to the direction of the sunlight. First method to produce a SMA is using casting method. One of the most important aspects of the casting process is to maintain the purities of the metal. There are several techniques involved in the casting process, such as vacuum induction melting, vacuum arc melting, and electron beam melting. The second method that can be used to produce SMA is the powder metallurgical method. So the basic steps are powder blending and then mold compaction and then sintering using a furnace. And the techniques for it is as follows in the picture. Solar photovoltaic is the rooftop solar mainly used in homes and industry. Solar photovoltaic is a technology that converts sunlight into direct current electricity by using semiconductors. Solar thermal technologies use sun's energy to generate heat and electricity. And electron capture valence and set the electron free and cross the p-n junction. Third, p-n junction as the one-way membrane will hampers the electron's movement. Fourth, negative voltage appears on the surface facing the sun. Nickel and aluminum can be found in computer chips, batteries, metallic components of cathode ray tubes, printed circuit boards of mobile phones and a computer. The recovering methods are mechanical separation, thermal treatment, hydrometallurgical treatment, and electrochemical treatment. And for copper, it can be found in PCBs and other IT or telecommunication devices. And the recovering method is oxidative acid leaching process.
Analysis. 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 Nickel is utilized in many aspects in our life because of its benefit. Nickel can also give a negative impact on the environment. That's why we need an alternative way to reuse and recycle nickel, which mainly comes from electronic waste. Copper and aluminum are very common in electronic waste, mostly available in PCBs and screen-related products, such as TVs, laptops, and mobile phones. Copper and aluminum are being used because of their conductivity, price, and worldwide existence. The table of nickel content in e-waste is as follows. The table of copper and aluminum content in e-waste is as follows. We are taking Bandung as our sample to calculate the amount of nickel, copper, and aluminum that can be recovered from e-waste of computers and its components. The data source is from the research on e-waste by Environmental Engineering, Bandung Institute of Technology. From the computer upgrade and repair services, many waste generated. In total, we have 99,000 kilograms of e-waste that can be a subject of nickel, copper, and aluminum extraction in a year. Referring to previous tables, we are assuming the nickel, copper, and aluminum content from e-waste. The amount of nickel that can be extracted in a year is nearly 2,000 kilograms. The amount of copper and aluminum are about 30,000 kilograms a year,
and 15,000 kilograms a year respectively. So, if we can collect the same amount of titanium from the mine or other sources, we could gain almost 4,000 kilograms of nitinol shape memory alloy a year. Other than that, if you are trying to make a copper, aluminum, and nickel shape memory alloy, under the assumption of the ratio above, we will have approximately around 40,000 kilograms shape memory alloy each year.
PESTEL Analysis, Politics and Legal. Recalling the Indonesian Government Regulation Number 20/2005, research and development to products related to technology is supported by the government. Economy. With nitinol approximation of 4,000 kilograms per year, we could gain 103,000 USD per year. With copper, aluminum, nickel approximation of 43,000 kilograms per year, we could gain 113,000 USD per year. This amount is excluding the manufacturing and extracting costs and some losses if there's any. Social. Based on the Jakarta Post, Indonesian electricity demand is increasing every year because of the society's increased use gadgets and electronic devices. Therefore, Indonesia needs to cover almost 100% electrification rate of its citizens by 2030. Technology. Indonesia's existing technology may not cover every type of extraction processes. Yet, to conduct a simple mechanism, most green companies in Indonesia are already able to conduct these processes. Environment. The increased effectiveness will help the plant to produce bigger electricity. This will slowly reduce the use of coal plant that contributes to carbon dioxide contamination in the air. Nusa Tenggara Timur is one of the Indonesian islands that is lacking electricity even though they have the nation's biggest solar power plant. Their solar power plant can be developed through certain mechanisms and products. For example, the shape memory alloy actuators. This development supports all of the PESTEL aspects mentioned above.
So here is the possible implementation of SMA in solar PV. So the shape memory alloy can be placed beneath the corner of each solar photovoltaic and simulated in a computer. The system will be as displayed. The trajectory of the shape memory alloy placed in the corner of the solar photovoltaic will be as displayed above, with the average temperature of Kupang, Nusa Tenggara Timur from January 2019 until October 2019 as depicted. So this is the table that shows the correlation within our IDs and SDGs. So part of the IDs that correlates with the SDGs is the first one is the extraction of electronic waste. It correlates, it embraces the three sectors, which is health, environment, and social sectors. And the second part of the ID that correlates is industrial development and social responsibility that embrace the sector of energy, economy, and social. Conclusions and recommendations. So the conclusion, the first one is to extract nickel and aluminum, we have to take several steps. The first one is mechanical separation, thermal treatment, hydrometallurgical treatment, and electrochemical treatment. And for extracting copper, we use oxidative acid leaching process. The second one, we could approximately gain around 43,000 kilograms per year of copper, aluminum, and nickel as the materials we use to produce shape memory alloy. And the shape memory alloy itself can be used as the solar photovoltaic system as the mechanical actuator. And this ID could embrace around 8/17 goals, which are goals number 3, 6, 7, 8, 11, 12, and 14, and also 15. So finally, we have 3 recommendations about the topics. The first one is to conduct experiments to see the real movement of the shape memory alloy when it radiated by the sun. The second one is to simulate it both in a computer and in real life to understand the possibility of error and effectiveness of the IED when we put in different conditions. And the last one is to develop another segment of the IED to use shape memory alloy as the smart microactuator other than the aforementioned IEDs.